Let's go over formative assessment, problem number 4 for correcting that problem. Number 4 states, determine both the linear and exponential regression equations. So we are going to have to do some regressions here, given this table. So we will have to use Desmos. You cannot do this problem without using Desmos. You're going to have to go into Desmos and type that data in. Do not forget, please, the regression formula that you must type into Desmos for linear is y sub 1 squiggly line m x sub 1 plus b. For the exponential, it's y sub 1 squiggly line again b times r to a power of x1. And please, when you're doing the exponential, you do want to activate what's called log mode. So you'll see a little box and that allows you to then check and activate that log mode. So we go to Desmos and we're going to enter in this specific data. Once we've done the regressions, we'll record those regression equations. And then don't forget, it does say circle the equation of best fit using the value of the correlation coefficient R. So as we're in this regression, we're going to have to be checking that correlation coefficient. Now I go ahead and go to Desmos. Now I've already got the data entered in. If you want to go step by step, you could pause the video and go ahead and enter the data. Now once you have the data entered into, you hit plus sign and you create a table, enter your data. You go over here and I can't see anything but 1 point. 0, 10 is the only point I can see right now. I want to adjust my window. So I click on the wrench, go to my X settings here, and what is the smallest X value here? The lower bound is 0, so I type that in. I hit tab. What's the largest X value? 600, so I type that in. Then I go down here to my Y values. My smallest, least Y value, the lower bound is 10, so I type 10. Hit tab and go over. The largest Y value is 350, so I type that in. Now those values, entering those values, the upper and lower bounds, are not going to give me the perfect window. I may have to zoom out just a little bit still to see that data. All right, but it does give me a good starting point. Now I'm going to go ahead and do those regressions. So I scroll down here, type y1. I'm going to do the linear regression, mx1 plus b. And as you can see, I get a pretty nice fit line to go through there. I'm going to change its color a little bit so it's not the same color as the points. Make it red. All right. Now look here. They tell us the slope is going to be 0.575. So when you go to record your regression equation, you have 0.575 is your slope and negative 2.5 is your y-intercept. So it goes to you go to record that. That's easy to find. Also make note, the R value right here, the correlation coefficient is 0.9977. That means that there's a very strong, the closer that is to 1, the better. And so that's a really strong correlation, meaning this data fits really well. Now we're going to go, I'm going to erase this really quick and we'll do the exponential regression. So you go back and you click and we do the exponential regression. Shift 6 gives you that exponent, remember? And don't forget, this is what I was talking about earlier. Don't forget to click on activate the log mode. That does make things look a little different. All right. Now we get a B value of 22.3747. That's the B value. We have an R of 1.00533. And we have a correlation coefficient of 0.9232. 0.9232. Keep that in mind. We go back to our quiz. We enter in those functions. The linear regression, don't forget, the linear regression was, when you have y equals here, I'm fine with that. 0.575 x, minus 2.5. I just rounded those off a little bit. I'm not judging your rounding, okay? That's not what we're grading on. The exponential, the starting value they gave us in the regression was 22.4. Again, I'm rounding that off a bit. And then the multiplier was 1.005 to a power of x. So I've recorded those two. Again, those are coming straight from that information that we found when we did our regression, these values that were given to us. Now, don't forget, the linear regression had that R value that was extremely high, that 0.9977. So this linear regression, this function is the one we're going to circle. It is the stronger correlation of the two. Remember, they said circle the equation of best fit. So we've circled that. And now we're going to use it. They want to know what is y when x equals 750. So we're going to use the one we circled. So we're going to say, what is f of 750? And we're going to use the linear up here. We're going to use the linear equation because it was the better fit. And we take our 0.575 times 750, right? We're putting this in for x. And then subtract 2.5. Then we crunch that through our calculator. We enter this into our calculator, and we get the result, which is 428.75. That's where that number's coming from. We had to choose the right function to plug this into. You always use the one of best fit. Thank you.